Welcome to the lesson on the overview of battery electric vehicle, abbreviated as BEV components. In this lesson, you will learn the key elements of a BEV that will help you to accurately identify and understand the functionality of each major component. Let us look at our lesson objectives. By the end of this lesson, you will be able to identify and name the main components that comprise a BEV. After we discuss the BEV components and provide their purpose and functionality, you will be able to describe each component. You will also be able to understand the overall functioning of a BEV and explain how the components work together, interact, and collaborate with one another. This is a generic illustration of the internal structure of a BEV. We will explain the overview of a BEV by providing the sequence of events that occur when a BEV is plugged in or when the battery has enough charge. We will also provide you with an overview of the main components of a BEV, namely the charge port, the onboard charger, the high voltage battery pack, abbreviated as HV battery pack, the electronics controller, the electric traction motor, the transmission, the direct current to direct current converter, abbreviated as DC to DC converter, the auxiliary battery, and the thermal system for cooling. Please note that manufacturers have flexibility when designing BEVs. The design, location, configuration, and name of components may vary among models and manufacturers. This is because manufacturers have different design philosophies and priorities. For example, some manufacturers prioritize performance, while others prioritize efficiency or safety. The location of components can vary among different models and even generations of the same model. Therefore, it is crucial to refer to the manufacturer's guide for the specific make, model, and year of a BEV that you are working on. Let us now look at the charge port. The charge port connects the BEV to an external power supply to charge the high voltage battery pack. The charge port is also referred to as the charging connector or the charging point. A BEV charge port is like a special socket where you plug in a cable to charge the car's battery. Just like you plug in your phone to charge it, the charge port connects the charging cable to give power to the BEV. The charge port is usually located on the exterior of the car, and it has a specific shape that matches the charging cable. There are different types of charging connectors, so the charge port is designed to fit a particular kind of connector. To charge a BEV, locate a charging station or an outlet with a charger. Plug one end of the connector into the charge port of the car. The other end of the connector goes into the charging station or the power source. The charging process begins once the connector is connected and electricity flows from the charging station into the vehicle's battery. The charge port has some safety features as well. It may have lights or indicators to show you that it's properly connected, and some charge ports can lock the cable in place to keep it secure while charging. These safety features help ensure that the charging process is safe and reliable. Let us now look at the onboard charger. It is a device that converts alternating current, abbreviated as AC, from an external power source to direct current, abbreviated as DC, which can be used to charge the battery pack of a BEV. This conversion process involves transforming the voltage and regulating the charging current to match the battery's requirements. It monitors the charging process to ensure the battery is charged safely and efficiently. It manages factors such as voltage levels and current flow to protect the battery from overcharging or overheating. The onboard charger is typically located in the trunk or under the hood. When you plug a BEV into a charging station or an outlet, the onboard charger allows the vehicle to accept and process the incoming AC power. It is integrated into the charging system. The size and capabilities of the onboard charger can vary depending on the specific BEV model. Some BEVs may have larger onboard chargers that can handle faster charging speeds, while others may have smaller chargers designed for slower charging. Note that the onboard charger is distinct from the external charging station or wall charger. The charger within the vehicle is responsible for converting the AC power from the external source into DC power to charge the battery, while the charging station or wall charger is the device that supplies the AC power to the onboard charger. Let us now look at the high voltage battery pack, abbreviated as HV battery pack. It is also referred to as the battery pack, power pack, or the traction battery pack. So, what is a high voltage battery pack? It is a collection of individual batteries or cells that store electrical energy to power the vehicle. These batteries are usually rechargeable and are typically lithium-ion batteries. It is called a high-voltage battery pack because it is primarily responsible for providing power for vehicle propulsion or traction. The term traction battery pack helps to emphasize the primary purpose of the battery pack, which is to propel the vehicle rather than simply providing power for auxiliary systems. It helps to differentiate it from other types of batteries used in different contexts, such as stationary batteries used for backup power or energy storage. It identifies a specific function within the vehicle and distinguishes it from other battery applications. The high-voltage battery pack is the main source of energy that powers the electric motor, allowing the vehicle to move forward or backward. It plays a crucial role in providing range and performance capabilities. Next, we have the electronics controller. It could also be referred to as the battery interface control module, the battery energy control module, or the motor controller. So, what is an electronics controller? It is a device that controls the flow of electrical power in a BEV. It is responsible for converting DC power from the battery into AC power that can be used by the motor and for regulating the power output of the motor. The electronics controller manages the flow and distribution of electrical power between the battery, electric motor, and other components. It also controls the speed and torque of the motor. Torque is the turning or rotational power of the engine. You may have also heard it described as a car's pulling power. The more torque a car can produce, the quicker it accelerates and reaches top speed. The electronics controller can even be used to brake the vehicle by converting the motor into a generator. It is a complex device that requires a high level of precision and efficiency. The electronics controller is critical to the vehicle's performance and efficiency. Next is the electric traction motor. It is also referred to as the drive unit, drive motor, electric motor, or the traction motor. So, what is an electric traction motor? It is an electric motor that is used to propel a BEV. The electric traction motor is responsible for converting electrical energy from the battery into mechanical energy. It is the primary source of propulsion and is responsible for delivering the power needed to drive the wheels. Electric traction motors are typically located in the front or rear of the vehicle, sometimes both in the front and the rear, and are connected to the wheels through a transmission. The type of electric traction motor used in a BEV depends on several factors, including the vehicle's size, weight, and performance requirements. For example, a small city car may use an induction motor, but induction motors are less efficient and more prone to noise and vibration, while a larger SUV may use a permanent magnet synchronous motor, abbreviated as PMSM. Permanent magnet synchronous motors are the most common type of electric traction motor used in BEVs. They are relatively quiet and have a long lifespan. The basic components of a BEV traction motor include a rotor or a rotating part and a stator or a stationary part. There are several different types of electric traction motors that are used in BEVs. The most common types are DC, AC, and induction motors. Let us now look at the next BEV component, namely the transmission. It is also known as high-voltage transmission, direct drive unit, and direct drive transmission. So, what is a transmission? A transmission is a component that transmits power, so in the strictest sense, every car has a transmission. It is responsible for transferring power from the electric motor to the wheels. Unlike traditional internal combustion engine, abbreviated as ICE vehicles that often have multi-speed transmissions, BEVs generally use a single-speed transmission. In a single-speed transmission, there is only one gear ratio available, meaning the electric motor is directly connected to the wheels. This allows the motor to operate at a constant speed while the vehicle is accelerating, meaning going faster, or decelerating, meaning slowing down. This allows the BEV to always operate at its most efficient speed. Some BEV models, like the Porsche Taycan, may incorporate a multi-speed transmission, although it is less common. Multi-speed transmissions feature multiple gears, allowing the motor to operate at different revolutions per minute, abbreviated as RPM ranges for improved efficiency and performance. RPM refers to the number of rotations the electric motor completes in 1 minute, indicating the speed at which the motor is operating. The decision to incorporate a multi-speed transmission depends on several factors, such as the desired performance characteristics, efficiency targets, and cost considerations. Overall, the type of transmission used depends on factors, including the vehicle's power requirements, the transmission's cost, and the desired performance characteristics. Let us now look at the next component, the direct current to direct current, abbreviated as DC to DC converter. It is also referred to as a voltage regulator and voltage conductor. So, what is a DC to DC converter? The DC to DC converter is a device that converts a source of direct current from one voltage level to another. It converts the high voltage DC from the main battery pack to a low voltage DC that is suitable for powering the vehicle's auxiliary systems and charging the 12-volt battery. This includes the motor, the inverter, the electronics controller, and the auxiliary systems such as the lights, the heating, ventilation, air conditioning, abbreviated as HVAC system, and the infotainment system. While the DC to DC converters can be based on several different designs, the underlying function remains the same. The batteries of a BEV typically output several hundred volts of DC. However, the electric components inside the vehicle vary in their voltage requirements, with most running on a much lower voltage. This includes the radio, dashboard readouts, air conditioning, and inbuilt computers and displays. In vehicles that use a DC motor, running the motor can use up to 3 times the voltage the battery provides. With the help of a DC converter, this gap can be bridged without resorting to a larger, heavy battery. The DC to DC converter plays a crucial role in distributing power throughout the vehicle's electrical system and ensuring the smooth operation of various components. The next component is the auxiliary battery. It is also commonly known by various names, such as the 12-volt battery, the accessory battery, the backup battery, or the auxiliary power unit, abbreviated as APU. So, what is the auxiliary battery? It is a small 12-volt battery that is used to power the low-voltage electrical systems of the car, including the lights, the radio, the heating, ventilation, air conditioning system, and the infotainment system when the main battery is in use. This is because the main battery is a high-voltage battery that is not designed to power the low-voltage electrical systems of the car. The auxiliary battery can also be recharged by a separate charger. The auxiliary battery is typically located in the trunk or under the vehicle's hood. It is a small, sealed battery like the type of battery used in a gasoline-powered car. The auxiliary battery is a vital part of the BEV's electrical system. Without it, the car would not be able to operate many of its essential functions. Lastly, we have the BEV's thermal system for cooling. It is also commonly referred to as a thermal management system, liquid cooling system, or battery cooling system. So, what is a thermal system? It is a system that controls the temperature of the battery, motor, and other components. The thermal system is important for ensuring the vehicle operates efficiently and safely. The thermal system consists of the coolant, heat exchanger, pump, and sensors. The coolant is a liquid that circulates through the battery, motor, and other components to remove heat. The heat exchanger is a device that transfers heat from the coolant to the ambient air, typically 78% nitrogen and 21% oxygen. The pump circulates the coolant through the thermal system. The sensors monitor the temperature of the battery, motor, and other components. The thermal system is controlled by the BEV's computer. The computer monitors the temperature of the battery, motor, and other components. If the temperature gets too high, the computer will activate the cooling system to remove heat. If the temperature gets too low, the computer will shut down the cooling system to prevent the battery from freezing. Without a properly functioning thermal system, the vehicle could overheat or freeze, which could damage the battery or other components. Let us recap the key points we have covered in this lesson on the overview of BEV components. Electricity flows in sequence when the BEV is plugged in, or the battery pack has enough charge. The charge port is where the BEV connects to an external power supply to charge the high-voltage battery pack. The onboard charger plays a vital role by converting AC power from a charging station into the DC power needed to charge the vehicle's high-voltage battery pack. The high-voltage battery pack serves as the main energy storage system, storing electrical energy to power the electric motor and propel the vehicle. The electronics controller manages the flow and distribution of electrical power within the vehicle, ensuring efficient operation of the electric motor and other components. The electric traction motor is the heart of the BEV, utilizing power from the high-voltage battery pack to drive the vehicle's wheels, providing the necessary propulsion. The transmission transfers power from the electric traction motor to the wheels, enabling efficient transfer of torque for the vehicle's movement. The DC to DC converter converts the high-voltage DC power from the high-voltage battery to the low-voltage DC power required for the auxiliary systems and for charging the 12-volt battery. The auxiliary battery supplies electricity to power the vehicle accessories, ensuring the smooth operation of various electrical systems and components. The thermal system, including cooling mechanisms, maintains optimal operating temperatures for various components, particularly the high-voltage battery pack, ensuring performance and longevity. Understanding the interactions of the main components is essential to grasp the fundamental workings of a BEV. It is important to remember the significance of these components and how they work together. Thank you.